Hello students, once again welcome you to GK's maths classes. Today we are going to introduce a new chapter called linear programming problem. Okay, this is used for mathematics as well as for applied mathematics. Okay, so today what I'm going to do is I'm going to introduce you to the concept of linear programming problem, and we are going to solve different types of problems, okay, without forming the equation. For Cbse class 12th mathematics, formation of linear programming problem is not there. We are only there to solve the LPP problem. The system of equation will be given and you have to solve it graphically, okay. Whereas for applied maths, we have formation and also solving, which we will do in the subsequent videos, okay. So today I will be doing it in a broader sense, that we are going to take around 4 to 5 problems and talk about different situations in a linear programming problem where the equations will be given to you, okay. So let us make a beginning, okay. Now what is a linear programming problem? A linear programming problem is a mathematical model, okay, of a business. It's a mathematical modeling of a business. So when you are doing a business, there are certain things that you should have in mind. The most important thing about a business is an objective. I need to have an objective to start a business. Maybe I want to maximize the profit, okay. So either I want to minimize the cost. So there must always be an objective. So the objective is nothing but it is called the objective function, okay. And it is called linear programming problem because all my equations are going to be linear equations, okay. So it is linear, it is not quadratic or cubic. All the constraints and objective functions, everything will be linear. Now in objective function, you will have either maximize or minimize. You have to optimize a problem, okay. Either you maximize the profit or minimize the cost, okay. So we have an objective function. An objective function is always denoted by z, is a symbol that we use, z, which is nothing but ax plus by. It's a linear equation. A linear programming problem is one which is concerned with finding the optimal solution, that is maximize or minimize. So z is a linear function. So I will write either maximize or I will say minimize. Minimize z equal to a. That is my objective. Either I have to maximize the problem or I should minimize it, okay. And this x and y are called decision variables, or otherwise called variables. This x and y are called decision variables. See this? It's a decision variable. So a linear programming problem should have, first of all, an objective function. What is an objective function? It should have an objective. It is about optimizing a problem. Either you maximize or minimize. Maximize or minimize is denoted by z equal to a linear function of x and y. What is x and y? X and y are decision variables. Then it should have a constraint. Now what is a constraint? When you do business, there is a lot of constraints. Like I have a capital constraint. Suppose I say I have only 1 lakh rupees to start the business. That means I don't have more than that, okay. I have only, I can employ 5 men and 4 women to do a job, okay. So that's a constraint for me. Transportation is a constraint. Raw material is a constraint. Getting a land is a constraint. So all the constraints that we have in doing a business is given by a linear inequality. Is given by linear inequality involving x and y. Linear constraints. That is why it's called linear constraints. As I told you, there are different types of constraints. Capital constraint, allocation, land is a constraint, labor is a constraint. There are many constraints. And finally, an LPP should have non-negative constraint. Every LPP should have x greater than or equal to 0, y greater than or equal to 0. So an LPP should have 3 things. First one is the objective function, second one is the linear constraints, and third one is the non-negative constraint, okay. So you know what an objective is? Objective is either you maximize or minimize. That function is given as a linear expression of x and y. What is x and y? X and y are the decision variables governing the business. And linear constraint, I told you there are different types of constraint. It is given by a linear inequality. And non-negative constraint is either you can have x greater than or equal to 0, and you should have y greater than or equal to 0. And there are certain terms like feasible region and corner points. Now what is a feasible region? A feasible region is nothing but a common region determined by all the constraints. So when I have the constraints, and wherever the constraints overlap, I call that as the feasible region. And corner points are nothing but, suppose if you get a feasible region which is a quadrilateral, the vertex of that quadrilateral is the corner points. Okay, so we will understand more in detail about these words when we actually start doing the problems. Okay, so let's go to the first problem. You know, in linear programming problem there are different types. So I am going to do one problem from each type just for a sample. Now for the first problem is, this is actually bounded, the solution will be bounded, and it has unique solution. So this is type 1. Okay, I have selected problems which is bounded and it has unique solution. What it is, we will see when we in the course of the problem. Okay, now if you notice this problem very carefully, it has an objective function. What is the objective function? Maximize z equal to 6x plus 3y, subject to the constraints. There are 3 constraints given: 12x plus 3y greater than or equal to 240, x plus 5y greater than or equal to 115, and 3x plus 2y is less than or equal to 150. Now how do I do these problems? Very, very simple. Just watch this. It's only time consuming, but otherwise it's not difficult. So first of all, you know 3 is common, so I get rid of it. So I get 4x plus y equal to 80. I will take the equality first. Okay. Now when I take the equality, as usual, I'll go for this calculation. X is 0, y is 80, y is 0, x is 20, correct? Now, then the next step is, you have x plus 5y equal to 115. Now draw the table. So what's the table like? X, y, x is 0, y is 23, y is 0, x is 115. Done. Correct? Now the third one is, you have 3x plus 2y equal to 150. Now what do I do with this? Again I solve this. This is x and this is y. X is 0, y is 75, y is 0, x is 50. Okay. Now everything is done. Now I want to draw the graph. Now how do I draw the graph? We have to be very, very careful with the graph. Okay. I am going to draw a rough diagram. So if there is any error, if you plot it on the graph sheet, it has to be done on the graph sheet. If you do it on the graph sheet, it should come out well. Okay. Now what's the maximum value of x? The maximum value of x is 115. And the maximum value of y is 80. Correct? So it's actually multiple of 10 I'm going to take. Okay, I'll take multiple of 10. So this is my x-axis and this is my y-axis. X-axis and y-axis. Maybe, okay, x-axis and y-axis. So what is this? This is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Okay. I don't have place, so I'll just move it to this side. I'll move this way. So 110, 110, I have it here. Now what about this? This is again 10, 20, 30, 40, 50, 60, 70 and 80. Now that's the maximum value I want, okay, 80. Now let's plot it. What is 0, 80? 0, 80 will be somewhere here, correct? 0, 80, let me use the red pen, 0, 80. And 20, 0. 20, 0 is here. Okay. Now I have to connect them by a straight line. Now how do I connect it? So it's come out well, correct? So this is the line. What is the equation of this line? 4x plus y equal to 80. So I have drawn the first line. Now it is 0, 115. 0, 23. 0, 23 will be somewhere here. Okay. 0, 23 and 115, 0. So 115, 0 will be here. Correct? So let me join it. Join by a straight line. I'll just take a copy of this. It passes through this and through this. Perfect, isn't it? So I got it. Maybe I should have drawn an x-axis and y-axis also with that line. Anyway, from next problem we'll do it. Now 0, 75. Where is 0, 75? 75 is here. 75 is here. And 50, 0. This is 50, 0. Let's see how it works. Join this and this. I got the line. Okay. Now what is the equation? Let's write the equations on top of it. So this equation will be x plus 5y equal to 115. What about this equation? This will be 3x plus 2y equal to 150. Now everything is done. Now it is time for us to shade. Okay. Now how do I shade this equation? That is very, very important. I need to find the feasible region. Okay. Now what is the feasible region? So first what I will do, I'll take the first inequality. What is the first inequality? 4x plus y is greater than or equal to 80. That is this line, okay? This line. So either it can be towards the origin or away from origin, correct? So I don't know where it is. So what I will do, I'll substitute origin and see. Wherever x is there, I put 0. Wherever y is there, I put 0. So I get 0 is greater than 80, which is not true, it is false. So this region is not towards origin, it is away from origin. It is away from origin. See this? It's away from origin. I hope you understand that. Now let's go to the next one. X plus 5y is greater than or equal to 115. That is this line. Can you see this line? This is the line. Either it can be towards origin, or it can be away from origin. I don't know, so I will choose origin. So when I substitute here, I get 0 is greater than 115, which is again false. So it can't be towards origin, it has to be away from origin. So how do I draw away from origin? So these are away from origin. I put a different color. Now finally, I come to 3x plus 2y less than or equal to 150. When I come to 3x plus 2y less than or equal to 150, that is this line, either it's towards origin or it is away from origin. So best way to do is substitute origin. You get 0 less than 150, which is absolutely true. So it has to be towards origin. So let's mark towards origin. Yeah, this is towards origin. So where is the overlap? Where do you see the overlap of all the three colors? The overlap of all the three colors can be seen here, right? Just a second. So this is my feasible region. Can you see it? So this is what you call a feasible region. And you see, feasible region is bounded. It is bounded by the three lines. Okay. And what are the corner points? These are called the corner points. The corner points are A. Sorry. The corner points are A. What happened here? A, B and C. Something is wrong. Let's see. I think it's not working properly. Okay, got it now. This is A, B and C. Now how do I find A, B and C? You can visualize it from the graph, or what you do, linear equation, you solve the equations. Okay, I generally like to solve the equation. I solve this equation and this equation. For example, I'll show you one. I will not be doing it for all problems, which will time waste. So for example, if you solve 4x plus y equal to 80, and I take this equation, what is this? This is 4x plus 20y equal to 420, 460, so 960. So what do you get? I get 19y equal to, so you get 960 minus 80, which is 0, 8, and I think you get 8, so 880. So what is y equal to? Four x plus 2y plus, I think this is 460, I'm sorry. This is 460, okay. Multiplying it by 115 multiplied by 5 multiplied by 4, I'm sorry, multiplied by 4, 20, yeah, 460. So when you subtract it, you get 380. So y is 20. Once you get y is 20, you can always find x. How do you find x? 4x plus 20 equal to 80. So 4x is equal to 60. So x is equal to 15. So my point A is 15, 20. Okay. Similarly, you should be able to find the remaining. My B will be 40, 15. And C is 2, 72. I think that is possible. You can solve these two equations. You'll get it. I think you can, just like I have shown you one, you can do the remaining. So these are called the corner points. Now how do I write the answer? A, B, C is the feasible region. A, B, C is the feasible region, and in bracket you write it is bounded. ABC is a feasible region and it is bounded. That's the first type. Now what are the corner points? The corner points are A. What is A? A is 15 comma 20, and B, what is that? 40 comma 15, and what is C? C is 2 comma 72. Now for all this you find Z. What is my Z? Z is nothing but 6x plus 3y. So at A, in place of x you put 15, in place of y you put 30. So what is my Z value? I have already calculated. My Z value comes out to be for 15 comma 20, it is 288. 228. For 40 comma 15, it will be 150. And for 2 comma 72, it will be 285. Now what is the question? Question is to maximize. So the answer will be the maximum value of Z is 285 for what? For x is equal to 2 and y equal to 72. So this is the complete problem which you are supposed to do if this question is asked. Now you see, this is bounded and it has a unique solution. It has only one point. It has unique solution. X is equal to 2, y equal to 72. So this is type 1, where I talk about a feasible region that is bounded and my solution is unique. I hope this is clear to you. Okay, just have a look at it once. So first I plot the graph, shade the region. To find the corner points, don't trust the graph, always solve the equations. I solve the linear equations. That is not too difficult. I have shown you one, so you can do the remaining. Find the corner points only by solving the equations. In that way the error will be, in fact it will be nil. Okay, and then you find whether it's a feasible region. Feasible region is bounded, corner point is there. Corner points you take and substitute the value of the corner point in Z and check which is maximum. Whichever is maximum, that is the maximum value. I hope this is clear to you. Now let's go to the second question. The second question is actually type 2. Now what is this type 2? First one was bounded unique solution. The type 2 will be bounded and infinitely many solution. Infinite solution. It is bounded and it has infinite many solution. It is bounded but it has infinitely many solution. Now how do I do this? Now watch this carefully. While doing this problem, okay, I will also explain to you some other details which you are supposed to know. Okay. Now first, as usual, let me plot the graph. So let us take the equation x plus 2y equal to 120. Now draw the table. If I draw the table, what do I get? I get x is 0, y is 60, y is 0, x is 120. The next equation is x plus y equal to 60. That will be like, again, plot it. X is 0, y is 60, y is 0, x is 60. Very obvious. Then you have x minus 2y equal to 0. So what I do, since all the values are multiples of 10, you start with 0. When x is 0, y is 0. Okay. When y is 10, x is 20. When y is 10, x is 20. So I have plotted the graph. I have calculated it. Now I am going to plot. How do I plot? Okay, now let's take the x-axis. This is my x-axis. Let's take the y-axis. Just a second, sometimes doesn't work. this is x-axis and y-axis. Now what is the maximum value of x? Maximum value of x is 120 and maximum value of y is only 60. So what I will do, I'll make this as 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Now this is like 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50 and 60. Okay. Now let's plot the first graph. Now what is the value? 0, 60. 0, 60 is here. 0, 60 and 120, 0. This is 120, 0. So I have to join this. So how do I join it? This one. And this goes straight there. Little adjustment you have to do. And you got the first equation. Now what is the equation? X plus 2y equal to 120. Now 0, 60 and 60, 0. So this is 0, 60 is there, this is 60, 0. So let's plot this. So 0, 60 and 60, 0. So what is the equation? X plus y equal to 60. X plus y equal to 60. The last one is 0, 0, 0, and 20, 10. 20, 10 is somewhere here. Okay. So let's plot this. So I have got this line. What is this equation? This is x minus 2y equal to 0. So I have drawn the graph. Now it's time to shade. Now how do I shade it? So the first is what I will do. I will take x plus 2y less than or equal to 120. So x plus 2y less than or equal to 120 means either it is towards origin or away from origin. So what I will do for convenience, I choose origin. So origin means 0 is less than 120, which is obviously true. So it is towards origin. So I will shade towards origin. Okay, all the region towards origin. Now the next one is x plus y greater than or equal to 60. So x plus y equal to 60 is here. So either it is towards origin or it is away from origin or towards origin. So I substitute origin because it's easy to calculate. 0 is greater than 60, which is false. So it can't be towards origin. It has to be away from origin. So it is away from origin. So it's away. Now finally what you do is you have the third one, which is x minus 2y greater than or equal to 0. Here you cannot substitute origin because the line is passing through origin. Can you see? The line is passing through origin. So when the line is passing through origin, if you substitute origin, you get equal to. So you cannot substitute origin. Whereas in these two cases, I substituted origin because the line is not passing through origin. Here you cannot substitute origin to test it. So instead what I do, I choose a point either this side of the line or that side of the line. Okay, either towards the y-axis or towards x-axis. So what I will do for convenience, I choose a point on the x-axis. So what is the best point on x-axis? Say 10, 0. That means wherever x is there, I put 10. Wherever y is there, I put 0. So I get 10 is greater than 0. Is it true or false? It's true. Since it is true, it is towards the x-axis. Where is towards x-axis? Towards x-axis, correct? Now where do you see all the shaded region? This is the feasible region. So go back to this, take this, and this is my feasible. This is my feasible region. Correct? Can you see it? This is my feasible region. And what do you say about the feasible region? It's bounded. Am I right? Because it is bounded by the line. So what do you say here? The vertex are, I'll choose the same points. The vertex are A, B, C, D. That is, I'll choose it as A. Yes, the vertex are A, B, C, D. You can choose in any order you want. So you have to write the feasible region. What is the feasible region here? A, B, C, D is bounded. A, B, C, D is bounded. A, B, C, D is bounded. And what are the corner points? The corner points are, what are the corner points? A, I think it is 60, 30. You can calculate. I'm not going to waste my time on calculation. Solve these two lines, you get it. Okay. If you want, I'll show you one more if you want. See, this is x plus 2y equal to 120, and this line, what is this line? X is equal to 2y. Okay, x is equal to 2y. This is x minus 2y equal to 0. So I'm going to solve these two. So what do you get? 4y equal to 120. Therefore y equal to 30. When y is 30, what do I get? X plus 60 equal to 120. Therefore x is 60. So it is 60, 30. So it is very it is easy. It is not at all difficult. Solve them, or if you plot it on a graph perfectly, if you are able to get the points from the graph also, you can take. But make sure it is accurate. And B will be, I have done the calculation, so it is 40, 20. And C will be 60, 0. And D is 120, 0. Correct? Now what are the Z values? My Z is actually 5x plus 10y. 5x plus 10y. Now how do I find the Z values? Substitute this. You get Z equal to, I have done the calculation, so I'll write it directly. It is 600. And Z equal to, it is 400. Z equal to, it's 300. And here Z equal to 600. Okay. There are two parts to this question. One is maximize, other one is to minimize. So first let me talk about minimize. So what is the minimum value of Z? Minimum value of Z is 300, where for x is equal to 60 and y equal to 0. So that finishes the minimization problem, which is bounded and unique solution. But it is also, suppose if they ask, say, maximize. For maximize, you have an issue. Look at the maximum value of Z. The maximum value of Z is 600. But unfortunately, you see 600 in two places. One is on vertex A, other one is on vertex D. One is on vertex A, other one is on vertex D. That means, you please make a note of this, very important. Maximum value of Z is 600 for what? For all points in the line segment, joining A and D. All, how many points are there? If all of them are solution. For example, I'll just take one. This is one point. Okay, this is one point. Now if I move this point around, okay, I'm not able to move it. If I move this point around, my z value will be the same. Okay, if I move this around, so it will take all values from a to d. That is why it is bounded and infinite solution. So this is something that you should never forget. Be careful about it. Is it clear? Now I will just show you this on a GeoGebra which I have done. Okay, I hope this will go to the next screen. HDMI. I think this HDMI. Just it will take few minutes. Just wait. I have solved this problem on GeoGebra. This is what I have got. Just have a look at it. It's exactly what we have done. Later on, I'll show you how to do it on GeoGebra. I'll put a separate video. This is exactly what I was talking about. Look at this value. Look at this z value. Okay? This is p of x comma y. This is 600, right? Now I'm going to move this e. Look at the e. So when I move this e, you see, when I move this e, my z remains the same. So it will take all values. It will take all values from d to c. Here I have taken as d and c. So all values from d and c. That is why this feasible region is bounded, but it has infinitely many solutions. I hope this is clear to you. Okay. I'll show you how to do this in GeoGebra as a separate video. Okay, that finishes type 2 problem. Okay, what is type 1? Type 1 is bounded and unique solution. Type 2 is bounded and infinitely many solution. Okay, now what's the third one? The third one is unbounded and unique solution. Here again it's a new concept. The third one is, what I'm going to do is unbounded and unique solution. This is the type 3. If you know these around 4 to 5 types of problem, you can do any question. Okay, the method is the same. So if you refer to this video and understand these types, I think the entire LPP is clear to you. So this is, first one is bounded and unique solution. Next one is bounded and infinitely many solution. Now we are going to do bounded and unique solution. Let us see, unbounded and unique solution. When the feasible region is unbounded, we have a lot of other things to do. So we'll go one by one and see how it is to be done. So the first step here is, I will take, as usual, draw the graph x plus y equal to 3. So I will start with the usual calculation. X is 0, y is 1, y is 0, x is 3. Fair enough, isn't it? Then I have x plus y equal to 2. It is only 2 constraints, so it's much easier for us. And the equations are also fairly good. X is 0, y is 2, y is 0, x is 2. Now the maximum value of x is 3 and maximum value of y is 1. So the graph is not going to be very complicated. Okay. So let's see how it goes. So I have the x-axis and the y-axis. So this is my x-axis, y-axis, and this is my x-axis. Okay. What are the points? The points are 1, 2, and 3. And this is 1, this is 2, and this is 3. So let's plot this. First I want to plot 0, 1. What is 0, 1? 0, 1 is here. And 3, 0. 3, 0 is right here. So join it. So now I think you got a perfect graph. What is the equation? The equation is x plus 3y equal to 3. The procedure is same for literally every problem. It's almost the same procedure. Okay, now let's plot 0 comma 2. Where is 0 comma 2? This is 0 comma 2 and this is 2 comma 0. Plot the graph. That's perfect. So what do I get? This is x plus, this is x plus y equal to 2. Now it's time to shade. Now how do I shade? As usual, we go back to our x plus 3y is greater than or equal to 3. So I substitute origin. 0 is greater than 3. It is false. So it is away from origin. So away from origin. So I'm going to take away from origin. It is not towards origin. It is away from origin. Now what's the next one? It is x plus y greater than or equal to 2. So I substitute origin and I also got 0 is greater than 2, which is yet again false. So it is once again away from origin. So this is away from origin, correct? So where is the overlap? The overlap is, this is the overlap, correct? So what type of feasible region I have got? I have got unbounded region. Am I right? This is unbounded. So it's infinite. Unbounded region. So what do you write here? The feasible region is unbounded. So it's totally different from what you have done before. Feasible region is unbounded. So what are the corner points? The corner points are these are the corner points A, B and C. So what is A? A is obviously 0 comma 2. B I can determine. C will be 3 comma 0. Now B, how do I find? I have to just solve these two. If you solve this, you can see 2y equal to 5. So I think that y is 5 by 2, correct? Y is 5 by 2 and 5 by 2 or 3 by 2. Let's see. Y is 1 by 2, correct? And y is 1 by 2, you get 3 by 2. So B is 3 by 2 comma 1 by 2. That's easy to solve, okay? 3 by 2 comma 1 by 2. Fine, very good. Now what is Z? Z is equal to 3x plus 5y. Z is 3x plus 5y. So what are the values of Z? Z is, for 0 comma 2 I am getting 10. Okay. And for this I will be getting 7. And for this I will get 9. And the question is to minimize. The question is to minimize. So when the feasible region is unbounded, this is something you should never forget. When the feasible region is unbounded, even though you see 7 is the minimum value, it may or may not be the minimum value. This 7 may or may not be the minimum value. So you have to check whether it is the minimum value or not by constructing something called the open half plane. Okay. So now what is this open half plane? Let's see what is open half plane is. Okay. Open half plane. So this is very, very important step. Many students forget this in the exam. Open half plane. Now take your Z. What is your Z? 3x plus 5y. If the question is to minimize, put less than. Don't put less than or equal to. It is only strictly less than. And what is the minimum value you have got? 7. Now this need to be plotted on the graph. Okay. So if you plot this, how do I plot this? You can take the equality just for the sake of calculation, and as usual we go for our calculation. Now please understand, one value will be 3 by 2 comma 1 by 2. Definitely it will be 3 by 2 comma 1 by 2, because that is where I got 7 from. The other one will be, when you put x is 0, y will be 7 by 5. What is 7 by 5? 1s are 5, 1.4. Okay, so let's plot this. How do I plot it? I want to plot that points now. So I will use green color. Okay, now I'm going to plot. What I'm going to plot? 3 by 2. Okay, I'll just circle it. 3 by 2 comma 1 by 2. Other one is 0 comma 1 by 4. 0 comma 1.4 will be somewhere here. Okay, now since it is less than, you cannot draw solid line, you have to draw a dotted line. So I'm going to draw a dotted line. Can you see that dotted line? This is the dotted line. What does this equation represent? 3x plus 5y less than 7. When I say dotted line, that means the points on that line don't belong to this region. Points on the line. If you ask me whether B lies on this region, no, because it is strictly less than. Less than means the line does not belong to this region. The line does not belong to the region. Don't forget it. Okay. Now what I should do? I have to shade it. How do I shade? Substitute origin. It can be towards origin or away from origin. When I substitute origin, I get 0 less than 7, which is absolutely true. Once it is true, I have to shade it. So I am going to shade that. I will use this blue color. Okay. So see this. This is my open half plane. Can you see it? This is my open half plane. This is my open half plane. Now if you see carefully, the open half plane and the unbounded region don't have any point in common. You may think B is a point that is common. It is not. B belongs to the open half plane because they are, all of them are having equal to sign. B do not belong to this red dotted line because it is strictly less than. The point on the line don't belong to the region. Okay. So here you have to make a statement. The open half plane, that is this blue shaded region, this open half plane, have no point in common, with the feasible region. The feasible region is this brown region. Have no point in common with the feasible region. If that is the case, we can straight away say z equal to 7 is the minimum value. Is the minimum value when for x is equal to 3 by 2 and y equal to 1 by 2. Suppose the open half plane and the unbounded region have even one point in common, you can say 7 is not the minimum value and this problem cannot be minimized. Is that clear? So this is a very, very important statement. If the feasible region is unbounded, it is mandatory that you have to draw open half plane and check whether the open half plane have points in common with the feasible region. If the open half plane have points in common with the feasible region, if the question is to minimize, then it will not have a minimum value. If the question is to maximize, it will not have maximum value. If the open half plane have no point in common with the feasible region, then that 7 is the minimum value. Okay. Now here I took less than because it's a minimization problem. If the question is maximize, I would have taken greater than 10. Okay, I would not taken greater than 7. I would have taken greater than 10. I hope this problem is clear to you. Okay, I just want to show you what I've done in GeoGebra, just for your understanding. Quickly, we'll just go through it. Just a second. Okay. I think you should be able to see it in a few minutes. Just a second. Now look at this. This is exactly the graph that I've drew. Okay, this is my unbounded region. Okay, sorry. This is my unbounded region. This dotted line is that 3x plus 5y less than 7 open half plane, and this blue color is the open half plane. So you can see clearly this light blue and dark blue, they do not overlap. They have no point in common. Therefore, the minimum value is 7 at 3/2, 1/2. Is it clear? So I thought this will be useful. How to solve problem using GeoGebra, I'll tell you later, so that it will be enrichment for you. Okay. Now next one. Sorry. Okay. Now this is the fourth question. We have totally 6 questions. This is the fourth question. Now what is the fourth question? The fourth question is actually unbounded. This is type 4. It is unbounded. It is unbounded and infinitely many solutions. Sorry, unbounded and maybe unbounded and infinitely many solutions. Infinitely many. This is type 4. So what are the types we have done? Bounded unique solution, bounded infinitely many solution. Third one is unbounded unique solution. Now I am going to do unbounded infinitely many solution. Okay. So let us go to the graph. So this is 3x plus 3x. Sorry. This is 3x plus 4y equal to 8. As usual, you have to draw the graph. Okay, there is no other choice. So I have already done the calculation. So when x is 0, y is 2. When y is 0, I am getting 8/3. Okay, 8/3, which is roughly 2.6. Okay, just keep it like that. Then it is 5x plus 2y equal to 11. So what is that I get? When x is 0, y is 5.5. When y is 0, x will be 2.2. 11/5. Right? When y is 0, you get 11/5, which is around 2.2. So it's now time to draw the graph. Okay. Now how do I draw the graph? So this is my x-axis. As usual, let's go back to this x-axis, and then I have the y-axis. And the values are like 1, 2, 3, right? So let me take it as 1, 2, and 3. This is 1, this is 2, and this is 3. Okay, so let's plot the graph. I want to plot 0, 2. Where will I plot 0, 2? The 0, 2 will be here. 0, 2, and 2.6, 0. 2.6, 0 will be somewhere here. 2.6, 0. So let's join it. Okay, so what is the equation? The equation should be 3x plus 4y equal to 8. The next one will be 0 comma, oh my god, so 0 comma 5.5, I have to draw 5.4, I didn't see it properly, so I will rework on this entire thing. Okay. Sorry, so I need to stretch this a bit more. So this is 1, this is 1, and this is 2, and this is 3, this is 1, 2, 3, 4, 5, and 6. Okay. Now I need to plot 0 comma 2, 0 comma 2 is here. 0 comma 2 and 2.6. So now I have to join this. So I joined it. And what's the equation? The equation is 3x plus 4y equal to 8. Now it is 5.5. 5.5 is here. And 2.2 is somewhere here. So now I have to join this. So the equation will be 5x plus 2y equal to 11. Now since both are greater than, when you substitute origin, it will not be towards origin, it will be away from origin. That you can test it, okay? For this it will be away from origin, and for this also will be away from origin, because both will not satisfy origin. So my feasible region is unbounded. So let's take unbounded. So this is my feasible region. My feasible region is unbounded. Correct? So what I should write? Feasible region is unbounded. If the feasible region is unbounded, you know you have to draw open off plane. We'll come to that later. But before that, what is the corner points? The corner points are, what is the first one? The first corner point is 5.5 comma 0, correct? So let's take 0 comma 5.5, 11 by 2. And second corner point is, this is A. And the second corner point B will be, when you solve it, you will get 2 comma 1 by 2. I think that is possible to solve. And C will be 8 by 3 comma 0. See, this is 8 by 3 comma 0. Don't take it as 2.6, keep it as 8 by 3. Okay. So what are the Z values? When I substitute in Z, I am getting 440, and I get Z equal to 160, and surprisingly this is also 160. Both are 160, and the question is to minimize. Go to the type 2 problem. Okay. Now before that, first I should, if at all minimum, this has to be the minimum value. But let us see whether it is a minimum value or not. So what I do, I immediately say open half plane. Open half plane. What is open half plane? Open half plane is nothing but 60x plus 80y is strictly less than, because it is minimized, strictly less than 160. Now if you cancel the 0, you get 6x plus 8y is less than 16. If you cancel the 2, you get 3x plus 4y is less than 8, which is nothing but one of these equations, correct? 3x plus 4y greater than or equal to 8. So something is there. Now I want to plot 3x plus 4y equal to 8. I don't have to make any special effort because I already calculated it. Now I am going to draw. See how I draw the open half plane. Watch this carefully. This is A, this is B, and this is C, right? So I am going to plot this graph. How? Just visualize it. For you to differentiate, I will draw somewhere here, okay? This is my open half plane. Please understand, what I am drawing is wrong. It should coincide with that black line. It should coincide with this line, okay? Just to make you understand, to visualize it, I have drawn little away, okay? And since it is less than, it will be towards origin, right? So towards origin. Let's shade it towards origin. So this is my open half plane. Now clearly what happens? Open half plane have no point in common with the feasible region. That means z equal to 160 is the minimum value. Is the minimum value for what? For not just 2 points, but all points in the line segment joining, all point in the line segment joining B and C. For example, if I choose a point here, okay, for every point in between B and C, Z will be 160. So it has infinitely many solutions. Previous problem was unbounded unique solution. This is unbounded infinitely many solution. I hope this is clear to you. Okay. The GeoGebra of this problem, I will do it separately again, otherwise it's taking too much time. Okay. So we'll go to that. We'll go to the next problem. This is the 5th problem. I have one more problem to do so that all types of problems are covered. Now what is this question? This is another type. This is type 5, where you'll get unbounded. It's unbounded but no solution, isn't it? So you have done bounded unique solution, bounded infinite solution, unbounded unique solution, unbounded infinite solution. Now I am going to do unbounded no solution. You just visualize, you have covered almost all types of questions. Okay. Now let's go to this problem. So first of all, let me take the equations. First I will take difficult equation like x plus y equal to 5. It has both x and y, that is why I say it's difficult. And this is x and this is y. X is 0, you get y is 5, y is 0, x is 5. And this is x plus 2y equal to 6. And if I plot the graph for this, it's going to be a nice graph. X is 0, y is 3, y is 0, x is 6. And you know x is equal to 3 is a straight line parallel to y-axis at 0, at 3, 0. Okay. So the maximum value of x is 5 and 6, and the maximum value of y is 5. Okay. So I am going to draw suitably. So this is my x-axis and y-axis. So this is 1, 2, 3, 4, 5 and 6. And what about this? 1, 2, 3, 4 and 5. Good. Fair enough. 5. I am going to plot this graph. How do I plot this graph? First of all, I want to plot 0, 5, 0, 5 and 5, 5 and the line. Let's straight away connect it. What is this line? This is actually x plus y equal to 5. The next one is 0 comma 3 and 6 comma 0. And let me join it. Very nice. Now what is this? This is x plus 2y equal to 6. Now x is equal to 3. X is equal to 3 is a line parallel to y-axis at 3 comma 0. Correct? This is x is equal to 3. It's too big. So this is x is equal to 3. Now it's time to find the feasible region. Am I right? I have to find the feasible region. Now how do I find the feasible region? So x plus y greater than or equal to 5. Substitute origin as usual. 0 greater than 5. Absolutely false. So it will be away from origin. So away from origin. This is away from origin. Okay, this is away from origin. And then you have x plus 2y greater than or equal to 6. Substitute origin. It is not clear. X plus 2y greater than or equal to 6. Substitute origin. You get 0 greater than 6, which is again false. So it is again away from origin. So what is away from origin? This is away from origin. And x is greater than 3. I don't even have to think. It's greater than 3. So where do you see the pink, light blue and dark blue line? It's unbounded. Am I right? So I will choose this. So this is unbounded. So you see again the feasible region is unbounded. Correct? So what do I write? I just remove this. Okay. The feasible region is unbounded. So what are the corner points? The corner points are A. What are the corner points? I think I am getting 3 comma 2. Okay, this is corner point A, 3 comma 2. B, which is 4 comma 1. I think it's B, which is 4 comma 1. 4 comma 1. And C, that is 6 comma 0. C, 6 comma 0. And what are the corresponding Z values? The corresponding Z values are 1, minus 2 and minus 6. 1, minus 2 and minus 6. If I substitute there, I get it. 1, minus 2 and minus 6. But the feasible region is unbounded. So what is my job? I have to find open half plane. Open half plane. What is open half plane? Open half plane will be minus x plus 2y is less than minus 6, because minus 6 is the minimum value. So the question is to maximize. So question is to maximize. So it is greater than 1. Maximum value is 1. So it's greater than 1. It is to maximize. It is not minimize. So since it is maximize, I say greater than 1. So I take minus x plus 2y equal to 1 to plot the graph. Definitely one point will be what? One point will be 3 comma 2. Okay. So when x is 0, y is half. When x is 0, y is half. So where do I plot? One is 3 comma 2. That is this region. One is 3 comma 2. Other one is 0 comma half. 0 comma half is somewhere here. Now dotted line. Open half plane. This is my open half plane. Okay, open half plane. The dotted line indicates this. Now I need to shade. So substitute origin. When I substitute origin, I get 0 is greater than 1, which is false. So it cannot be towards origin. It should be away from origin. It should be away from origin. So let me shade away from origin. Okay, I am shading away from origin. Watch this. This is away from origin. When I shade away from origin, what happens? What happens in this region? The open half plane have points in common with what? With the feasible region. Can you see it? The open half plane have points in common with the feasible region. Then what happens? Therefore, z equal to 1 is not the maximum value. Not the maximum value. Very important. It is not the maximum. Therefore, it has no solution. It cannot be maximized. This particular problem cannot be maximized for this constraints. Is it clear? So, we have done 5 problems where first one was bounded unique solution, second one was bounded infinitely many solution, third one is unbounded unique solution, unbounded infinitely many solution, and finally you have come across unbounded but no solution. Last but not the least, we have one more question to do. So this covers everything. This is type 6. This is no solution, or you can say no feasible region. It will not have any feasible region. Let us draw this and see. You have x plus y equal to 8. If I draw x plus y equal to 8, and you have 3x plus 5y equal to 15. What is that? X is 0, y is 3, y is 0, x is 5. Now it's time to draw the graph. Actually, it's a very nice graph. X-axis and y-axis. Maximum value is 8, right? So it is 1, 2, 3, 4, 5, 6, 7, 8. 8, 7, 6, 5, 4, 3, 2, 1. And maximum value of y is 8 again. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I'm going to plot. I'm sorry, just move the screen. So I'm going to plot it now. So how do I plot 0, 8 and 8, 0? 0, 8 and 8, 0. So let's plot this line. Okay. The next one is 0, 3. 0, 3 and 5, 0. Let's plot this line. I have plotted it. Now it's time to shade. The first one is x plus y greater than or equal to 8. Substitute origin as usual. 0 greater than 8 is false. So it is away from origin. Okay. This is away from origin. Can I see that? Now 3x plus 5y less than or equal to 15. I substitute origin. 0 less than 15. It's true. So this is towards origin. So where is the overlap? So this problem has no feasible region. Therefore it has no solution. Therefore it has no solution. So this covered all types of questions that you can experience, okay, using graphically, how you solve a linear programming problem, okay. The formation of linear programming problem and solving it, I will do it in the subsequent video. So kindly subscribe to my channel and also click the bell icon to get notification. Sorry, this video is very lengthy. Okay, as I want to cover everything in one stretch. Okay, see you again in the next video. Have a nice day. Goodbye. Tata.